Hello all, welcome to the next lesson. In today's lesson, we will discuss interpolation formula for the unequal intervals. Yes, in the previous lessons, we had talked about lots of formulas like Newton's Gregory forward, Newton's Gregory backward interpolation formula, Gauss's forward interpolation formula. We had videos with Gauss's backward interpolation formula. We had a video with Stirling's formula, Bessel's formula. All these formulas were based for the equal intervals, equal spaces. And from today we will discuss the formulas which are for the unequal spaces or unequal intervals. For example, let's say if we have the data values where x is 1, 2, 7 and 8. You can see these intervals are not equal. From 1 to 2 we have the difference of 1, from 2 to 7 we have the difference of 5, and from 7 to 8 again we have a difference of 1. So which formulas we can use for unequal spaced data? Majorly we have two formulas. One is the Newton's divided difference interpolation formula and the other is the Lagrange's interpolation formula. Today's lesson we will talk about Newton's divided difference formula. So this is Newton's, it's also called as Newton's general interpolation formula, or we can call it as Newton's divided difference interpolation formula, and this is for unequal intervals. So let's see what is the formula. The formula says fx is equal to f of x0. Basically we can also call it y0. So this is f of x0 plus x minus x0, where x is the questioned value, x minus x0, f of x0 comma x1. This is the first divided difference called as the del of fx. This is the first divided difference. We'll see how we can calculate the divided difference and how we can create the divided difference table in today's lesson. Next is x minus x0, x minus x1, and divided difference, second divided difference del 2fx, that is f of x0 comma x1 comma x2. In the same manner, we can evaluate the further terms. Let's see what could be the next term. The next term will be x minus x0, x minus x1, and then x minus x2. And this will be the next divided difference, that will be f of x0, x1, x2, and x3, and so on. In this way, we can generate different terms of the Newton's divided difference formula. So we will see this, how we can do it with the help of an example. Before jumping to the example, let's see the formula for the divided difference. So if it is first divided difference, f of x0 comma x1, this is always equal to f of x1 minus f of x0 whole divided by x1 minus x0. So this is the first divided difference. Let me write, if I say that what is x2 comma x3, then this will be f of x3 minus f of x2 divided by x3 minus x2. So this is the first divided difference. Now let me write the formula for the second divided difference. So what will be the second divided difference? Let's say if we have to write x0, x1, x2. Now what will be the result of this? So we can say that the next difference will be f of x2 comma x1, this is the first divided difference, minus f of x1 comma x0 divided by, this would be the last element, this is x2, minus the first element, this is x0. So you can see this is the second divided difference. The first divided difference minus first divided difference, then x2 minus x0. We'll see this with the help of the example and we'll calculate all these divided difference. Then we'll substitute into the Newton's formula. So let's create this divided difference table first, and then we'll continue with the question. So you can see there is a question. We have the values of x, 1, 2, 7 and 8 unequal spaced. We have the values of fx, that is y, 1, 5, 5 and 4. And this is the questioned value. At x is equal to 6, we need to find out the value of fx. So we'll create the divided difference table. Right, so let us consider that this is x0, this is x1, this is x2 and this is x3. then this 1 will be f of x0, this 5 will be f of x1, this 5 will be f of x2, and this 4 will be f of x3. So this is f of x1, x0, this is f of x1, f of x2, and this is f of x3. Now let's calculate the divided difference here. This will be our f of x0 comma x1. This is the first divided difference in between these two values. So the formula for this will be f of x1 minus f of x0 divided by x1 minus x0. Now let's see, what is f of x1? F of x1 is coming 5 here. So this is 5. What is f of x0? This is 1. So 5 minus 1 divided by, what is x1? x1 is 2. So this is 2 minus, what is x0? So x0 is 1. So this is 2 minus 1 coming. 5 minus 1, this is 4 divided by 2 minus 1, this is 1. So this is coming 4. So let me write here the value of this first divided difference as 4. So let me write here, this is 4. Now let me calculate the first divided difference in the same column. So this will be the second value. We can write it as f of x1 comma x2. Now what will be f of x1 comma x2? This will be f of x2 minus f of x1 divided by x2 minus x1. Now what is f of x2? F of x2 is 5. So this is 5. What is f of x1? This is also 5. So minus 5. What is x2? This is 7. And what is x1? This is 2. So this will be 7 minus 2. So this is coming 0. We can see 5 minus 5 is 0. So this is coming 0. So in the place of here, let me write 0. So this will be 0. Next, in the same column, next divided difference will be f of x2 comma x3. This will be f of x3 minus f of x2 divided by x3 minus x2. Now what is f of x3? F of x3 is 4. So we'll write 4. What is f of x2? F of x2 is 5. So I'll write 5 divided by x3. What is x3? This is 8. So I'll write 8. Then what is x2? This is 7. So I'll write 7. So now this is coming 4 minus 5 minus 1, 8 minus 7, this is 1. So the result is minus 1. So let me write here in this place as a minus 1. So this will be minus 1. So this is the first divided difference. Now let me calculate this second divided difference. So the second divided difference first will be f of x0, x1 and x2. So now what will be the f of x0, x1 and x2? This will be f of the next value. So this is f of x1 comma x2 minus the previous value, that is f of x0 comma x1, and divided by, this is x2 minus x0. So this will be x2 minus x0. So now let me calculate the value. This is 0 minus 4 in the numerator, 0 minus 4 in the numerator, and in the denominator this is 7 minus 1. 7 minus 1. So this is coming minus of 4 divided by 6. Minus 4 divided by 6. So let me write this value here. This is minus of 4 divided by 6. So this is minus of 4 divided by 6. Now let me calculate this second del. This will be f of x1, x2, x3. And the formula for this will be the next value, which is f of x2 comma x3 minus previous value f of x1 comma x2. This is f of x1 comma x2 whole divided by x3 minus x1. So this is x3 minus x1. So what are the values? Let me substitute these values. This is minus 1 minus 0. So this is minus 1 minus 0 divided by x3 is 8 and x1 is 2. So this is 8 minus 2. So this is coming minus of 1 upon 6. So in this place, let me write minus of 1 upon 6. So now this is minus of 1 upon 6. And now let me calculate the third divided difference. Let me shift this a little bit. So this will be the last column, third divided difference for us. So this third divided difference will be, let me write the formula first. This will be f of x0 comma x1 comma x2 comma x3, and the formula for this will be first this value minus this value. So this will be f of x1 comma x2 comma x3 minus f of x0, x1 and x2, x0, x1, x2 divided by this will be the last value x3 minus x0. So this is x3 minus x0. So now let's substitute all these values into this. So this is minus of 1 upon 6 minus of 4 upon 6 whole divided by x3. What is the value of x3? x3 is 8, x0 is 1. So this is 8 minus 1. So this is coming 1 upon 14. So the last value is coming 1 upon 14. Let me substitute this value here. So this is 1 upon 14, right? 1 upon 4. So this is how we can create the divided difference table, and you can see we have all the values. We need f of x0 comma x1. So what is f of x0 comma x1? So this is f of x0 comma x1. The next we need is f of x0, x1 and x2. That is f of x0, x1 and x2. So we need this minus of 4 upon 6. And the next value will be f of x0, x1, x2 and x3. So this is 1 upon 14. These are all the values that we need into our Newton's general interpolation formula. So now let me use this formula and substitute all the values and then calculate the result for us. Let me write the formula here downwards. So now this f of x will be f of x0. What is f of x0? This is 1. So we'll write 1 plus x minus x0. What is x? The quotient value. This is 6. So we have 6 minus x0. What is x0? We can see this is 1. 6 minus 1 dot f of x0 comma x1. So this is f of x0 comma x1 from the table. So this is 4. Next we have x minus x0 dot x minus x1. So x minus x0 is 6 minus 1 and then 6 minus. Let's see what is the value of x1. This is 2. Dot. Then the value we need is f of x0, x1, x2. What is this? f of x0, x1, x2. This is minus of 4 upon 6. So this is minus of 4 upon 6. The next term will be x minus x0, x minus x1, x minus x2 and then third divided difference. So let me write the next term. This will be x minus x0, 6 minus 1, x minus x1, 6 minus 2 and x minus x2. So this is x minus x2, that is 7. So I'll write 7. And lastly, the third divided difference, that is f of x0, x1, x2 and x3, that is coming 1 upon 14. So these are the values that we can substitute. We can use the scientific calculator and we can calculate the result. So this is coming 6.2380. So this is the value of the x. This is the final result, that is f of x at x is equal to 6 coming to be 6.2380. So this is how we can perform the solution of the given data using the Newton's general interpolation formula or the Newton's divided difference formula. In the next lesson, we will be talking about the next formula, Lagrange's interpolation formula for unequal intervals. Thank you so much.